showcasing the SALIENT tool, which is a tool developed for identify safety critical concern in an unmanned aerial vehicle software platform. The approach is based on a machine learning pipeline which is able to automatically split sentences composing issue in a unmanned aerial vehicle repository and recognize safety concern. We have experimented our approach in open source project, very popular one, of unmanned aerial vehicles. So this repository has been organized in different sections, as you see here in the table of content, which overview the architecture of SALIENT, how to use it with a video, and then how to set up it for local development using, for example, the GUI or Docker container for easily install the SALIENT approach. And of course, we'll also provide different types of ways to interact with the tool, which is a command line interface and graphical user interface. So let's start first to understand a bit the architecture before going to more hands-on on how to use the tool. So the architecture of SALIENT has been developed to facilitate the selection of issue that can be imported through the pipeline of SALIENT tool, and developer can actually via command line or graphical interface edit issue, interact basically with the framework, and behind the framework there are two main components that have the intelligence to classify issues in safety concern. The first one is GitHub issue parser, which parser the issue text, pre-process it, split in sentences so that this information is digestible by the next component, which is machine learning component, which has a pre-trained model on previous issues data from unmanned aerial vehicle and is able to categorize safety concern, derive the one that concerns safety aspects and from more general concern. So this is more or less the overview of the pipeline, and I wanna clarify that again that the tool leverage here both a CI and a graphical interface. So I'm gonna to showcase first the graphical interface, then the command line tool behind SALIENT. And what is important to know is that we develop the pipeline so that it can be used for local development. What is important to do is to clone the repository, adhere to requirement for its usage, which have been tested in Linux and macOS machines. Once I have installed all required packages, it is possible to use the graphical interface and the command line tool to facilitate the process, especially in using the command line tool. We also provide a Docker version of the tool where it actually facilitates a lot the usage of the tool, we believe. Going back then directly to the graphical interface, I want to first give an overview how it works, and then we're gonna go to showcase it. So to run a graphical interface, what you have to do is go in the command line tool. After you have cloned the repository, you will see something like that locally, and then go basically in the subfolder where there is the source code that is required to be run, and then run the command specified as in the repository. In background, basically the tool will run or will open the graphical interface, which allows to do different things. First of all, open or copy and paste the text of issues from in our context for unmanned aerial vehicle projects. As you can see, it has been opened. And then it are allowed to read and classify text that has been opened from files, passed from open issue, and classify it automatically. We can also save results locally and then close, of course, the graphical interface when all our activity or task has been performed. So let's go on the graphical interface. So as you can see here, we can open file locally. For example, I'm going to open text of an issue that we used for our experiments, and basically you can edit the text if you want, and then ask the tool to classify the issue. As you can observe, the tool is able to identify sentences that concern safety issue, as in this sentence. Since the compass prioritization changed, however, this result is FKF, not using any compass, which is unexpected and potentially dangerous. That's quite important. You can also edit issue. What is important in the classification process you see in background in the pipeline is that classify sentences in dangerous related to concern, as it been observed also in the graphic user interface consistently, and provide probability for it. Of course, it's possible to save those results in a more consistent way rather than just visualizing from the command line interface. And what is important is just to select a location for the file, for example, results CSV. So if you go and observe the file or results, you will see that it creates a CSV file which has a certain format, the sentence, the predict label, which is the label that has been assigned, and its probability. So this can be used by developers to prioritize aspects that are more important from a safety point of view. That's was what I wanted to show you in terms of graphic user interface. I'm going to close it and come back to the next aspect I want to show you about the SALIENT tool. So as we have seen back to the table of content, we can access the tool via command line and a graphic interface. Now I want to demonstrate the interaction with the tool, the command line interface. What is important to know is that for running the tool, you have to run different commands, which is one shown here in the repository, but also here in the command line. Before executing it, I want to show and describe a few things. So this command execute a machine learning parameter that classifies sentences that have been provided as input using a config JSON file. This config JSON file has different parameters. The first parameter is the path model, which has and locate the pre-trained model used for classifying issues, and then provide different options to provide inputs if you want issue data. One in a CSV format, very structured, one more as a free text copied from an issue in a file, or even just as a text in the JSON file. And also it has to clarify where the data will be saved as outcome of the process of the classification. Let's see more closely this config file. As you can see here, you have to specify the location of pre-trained model, which is typically by default at least in the very same location, but you can provide also absolute paths to the location. What is important to know is that from the config file you can specify different input, different files that can be pre-processed for the classification. I'm going to show each of them. The text CSV is more a CSV format. You can provide an ID, generic ID, the link of the issue, the text of the issue, and the label that is not yet assigned. The tool will take this as input, this CSV set of sentences from the issue, and we classify them. Assuming you don't have a tool to split sentences, what you can give as input to the tool is just a free text, an issue copied from the repository, and then give as input to the tool. And the idea is that the tool can also, as we've seen before, also take as input just the text as input to the config file, so a sequence of sentences coming from the issue. So let's see what happens when using just as input one of these potential input, which is just a sequence of sentences, and what the tool actually does when running the command. Basically speaking, whatever input is given as input is actually executed, processed, and classified in terms of safety and non-safety concern, and stored in this local file. We'll see also that shortly. So let's run the command. As you can see, the command is quite fast and it labels sentences that have and concern safety concern and provider probability. As you can see, there are not a lot of sentences since they come from this specific input provided to the config file. But let's see what happens if we basically provide all these files that we've seen before as input. We save and we ask the tool again to classify issue. As you can see, the tool can simultaneously classify all these files and identify safety concern. As you have seen before, the results are saved in a local file that is specified as input. All sentences are assigned an ID and the sentence has a label that is concerning the safety probability with the actual probability next to it. So if an issue concerns safety or non-safety concern. That's quite important, I think, to make, and for us was quite important design choice to give you the possibility to provide input of issue in a very different format to give you the flexibility to work with the pipeline. So that, I think I'm going to conclude, says thank you for your attention. If you have any question about your the conducted research or the paper behind the research, we recommend you to look at how original works behind that inspired this pipeline, which concerned a paper concerning automated identification and qualitative characterization of safety concern reported in a unmanned aerial vehicle software, and papers concern more general bugs of cyber physical system. If you have issue in running the tool or have any inputs to improve the tool, just contact us as developers, original developers of the SALIENT tool. Thank you for your attention.